Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about Riemann sum tables.
Minute Math, when you need help you use Minute Math.
We're given this problem right here. We have the integral from 0 to 10 of f of x dx, and we have a table that corresponds with it, and we need to use the left-hand Riemann sum to approximate this integral. Okay, so we were given the table here, and so the first thing I'd like to do here is figure out the width of each one of our rectangles. So I find the width between each one of these x values. So the width between 0 and 2, well, is just 2. The width between 2 and 5 is a 3. Between 5 and 7 is 2, and 7 is 10 is 3. Okay, so these are our widths we'll be dealing with. Now they tell us this is a left-hand Riemann sum. So let's label it as left hand here. Okay? And the width or the area of each rectangle we want to find. Well, the width times the height, right? The area is the width times the height. So we take the width of a 2 and we have to multiply it by some height for this first one right here. Now I said it's a left-hand Riemann sum, so I go to the y value or the f of x value on the left-hand side, which is 2. Plus the next width, which is a 3, times the left-hand Riemann sum is that 3 value here. Plus the width of 2 right there, times again left hand 5, the height value, right? And the last width is a 3 times its height, which is a 7 on the left. Okay? And now we have to simplify this. Well, left-hand sum, we have the 2 times 2 gives us the 4, plus 3 times 3 is the 9, plus a 2 times 5 is a 10, and a 3 times 7, good old 21. Now we want to add all of these together, and it comes out to be a 44. And so a 44 is the approximation, right, using left Riemann sum of our integral function here. We're given this problem right here, the integral from 0 to 10 of f of x dx, and we will want to use the left-hand Riemann sum to approximate this integral based on the values in our table below. The first thing I want to do is see my x values here, and I want to find the difference between each x value there. That's going to give me the width of each rectangle. So between 0 and 4, width of 4. Between 4 and 6, difference of 2. 6 and 7, difference of 1. And 7 to 10, difference of 3. So we have our width right here, okay, for each rectangle. Now we want to do a left-hand Riemann sum. And so we need to take the width of each rectangle times the height. And so our width for the first rectangle is a width of 4, but its height, since it's left-hand, we use the left value, left y value of that rectangle, and left height is a 5. Same thing, next one, we have a width of 2 times its height on the left is a 3. Width of 1 is next, plus the width of 1 times its height of 2, the y value, right, f of x. Plus lastly, width of 3 times its height of 3. And now, let's simplify, okay? 4 times 5 is a good old 20, 2 times 3 gives me the 6, 1 times 2 gives me, well, 2, and 3 times 3 is 9. When we add all of them together, 20 plus 6 plus 2 plus 9, we get a 37. And so 37 is the final answer. It's when the left-hand Riemann sum, it's approximate of our integral based on the tables below. We're given this problem right here, the integral from 0 to 14 of f of x dx, and we're given a table below. We need to find the right-hand Riemann sum to approximate the integral based off that table below. So they first tell us it's a right-hand Riemann sum. Got to keep that in mind. Right here, these x values will represent the base parts of each rectangle. And so I want to find the width of each rectangle, the distance between each x value. So the difference between 0 and 3 is a 3, and between 3 and 5 is a 2. Between 5 and 9 gives me the 4. And between 9 and 13 we have another 4 as well, and 13 to 14 we have 1. And these represents the widths that we'll be dealing with, okay? Now they tell us it's a right-hand Riemann sum, okay, right hand. And so the area of each rectangle is its width times its height. So our first width of the rectangle we found to be 3. We need to multiply that by the height of that rectangle. And since it's a right Riemann sum, we use the y value or f of x value on the right side of that rectangle, and that y value be a negative 2. So negative 2 right here. Next one. We have a width of 2, multiplied by the right part of the rectangle, height negative 1. Plus a width of 4 is next, times its height 0, right hand side. Plus width again of 4 times its height negative 1. Then plus, lastly, a width of 1 times its height is 0. Okay? Alright. So now we just have to simplify this. Okay? Well, 3 times a negative 2 is a negative 6. Plus 2 times negative 1, a negative 2. 4 times 0, good old 0. 4 times negative 1, negative 4. And 1 times 0, 0. And this represents the area of each one of these rectangles for the right-hand Riemann sum. But we have to add them all up to get the total value, and when we add negative 6 plus negative 2 plus 0 plus negative 4 plus 0, we get a negative 12. And so using the right-hand Riemann sum to approximate this integral from 0 to 14 of f of x dx, we get a value of negative 12. We're given this problem right here, the integral from 0 to 19 of f of x dx, and there's a table that corresponds with it. We want to find the right-hand Riemann sum to approximate this integral based off the table below. First thing I want to do is I see my x values right here, and they represent the base parts of each rectangle. And so I want to find the width of each rectangle, the difference between each x value. So the difference between 0 and 4 is a 4. Between 4 and 9 gives me a 5. Between 9 and 10 is a 1. 10 and 12 is a 2. And 12 to 19 is 7. And that's our widths right there for each rectangle. Now again, they told us that this is a right-hand Riemann sum. Right-hand. So to find the area of each rectangle, we take its corresponding width, so in the first case we have a 4, and multiply it by the right part of that rectangle, its height. So the height of the right part of the rectangle refers to f of x, and the right part is negative 5. So we have a negative 5 being multiplied here. Plus, next width is a 5. Okay, multiply that by the right part, its height, negative 4. Plus a width of 1 here, times its height, negative 2. Plus 2, the next width, multiply its height, negative 1, plus, lastly, the width of 7, a large one here, multiplied by its height, just a positive 1. So let's go simplify this out. 4 times negative 5 is a negative 20. 5 times negative 4 is also a negative 20. 1 times negative 2, negative 2. 2 times negative 1, a negative 2 again. And 7 times 1 is a 7. Okay? So now we want to add all of these up. So now remember, each one of these represents the area of each one of our rectangles. Add them all together, and we get the approximate area below. Negative 20 plus negative 20 plus negative 2 plus negative 2 plus 7 is a negative 37. And that's it. Our Riemann sum, our right-hand Riemann sum, to approximate the integral based off the values below of our function is a negative 37. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.